Today we're going to be talking about exponents and what you can do with rational exponents, and that would be fractions as exponents. So I real quick want to review over the properties of exponents. So the first one is the product of powers. So if I have a to the m power times a to the n power, that's the same as saying a to the m plus n power. So if you see a times here, you're going to be adding your exponents together. So like 12 squared times 12 cubed is the same as 12 to the fifth. The quotient of powers works very similarly. If it's a over m, if it's a to the m divided by a to the n, that's the same as a to the m minus n. So if I had, say, 5 to the 7th divided by 5 to the 3rd, 7 minus 3 is 4, 5 to the 4th power. The power of a power says that if I take one power to another, like we do here, that's basically the same as multiplying the two powers together. So if I had 2 cubed to the 4th power, that's the same as multiplying the 3 and 4 powers together and getting 2 to the 12th. Another thing we can do is power of a product. So if I have a times b to the m, that's the same as saying a to the m times b to the m. That one's kind of like distribution. Then we have power of a quotient, which works kind of the same way. If I have a fraction to a power, both the numerator and denominator get multiplied by that power, just like in this example here. So I know in the examples I did really convenient whole numbers, but you can also do fractions, and fractions represent roots. So for instance, and let me write off to the side here, if I wanted to write maybe the square root as a rational exponent, so I said x square root of x like this, that's the same as saying x to the 1/2 power. If it was a cubed root, like this, that's the same as saying x to the 1/3 power. So let's take a look at what we can do with some of these. So number one here, I've got 25 to the 3/5 power, so that's cubed and then fifth root, times 25 to the 7/5 power, the 7th power to the 5th root. Now I see this times, and that means I'm going to do what? That's right, I'm going to add. So 3 plus 7 is 10. So I end up with 25 to the 10/5 power. And 10/5 reduces to 2. 10 divided by 5 is 2. So, and I can evaluate that all the way to 625, 25 squared. Over here, I've got the same thing, sort of, but I'm dividing. So I've got 8 to the 1/3 power divided by 8 to the 2/3 power. What I'm really going to do is subtract these two exponents, and 1/3 minus 2/3 is negative 1/3. When you have a negative power, that means that it's going to go on the denominator of a fraction. So I'm just going to put a 1 over this, and that'll give me 1 over 8 to the 1/3 power. And 8 to the 3rd power is 1/2. Let's do one with quotient of powers. This one's a little more exciting. What I'm going to do here is I've got y to the 4/3 over 16y to the 2/3, everything to the 3 over 2 power. So I'm going to do the stuff inside the parentheses first. I'm going to deal with these y's. So I've got my 4/3 minus 2/3, and I get 2/3. That's a positive, so it stays on the top. The 16 I didn't mess with, so it stays on the bottom. Now I can use the power of the power of power, and I can say, okay, y to the 2/3 times y to the 3 over 2. Those fractions cancel out, and I just get a y. And then I get 16 to the 3 over 2 power on my denominator, and I can simplify that to be 64. I would probably use a calculator to do that. That would be 16 squared, and then the cube root of that. So I can scooch over to the side here. There we go. And number 4 here, I've got 27x to the 3/4 power, that whole thing to the 2/3 power. So the first thing I'm going to do is kind of separate this out. I'm going to do 27 to the 2/3 power, and also x to the 3/4 power to the 2/3 power. So I'm going to leave the 27 term here kind of by itself. I'm not going to mess with it. And what happens when I do power and a power here? Well, it looks to me, if we go back up here, when it was a power to a power, is I'm going to multiply. We go back down here. That's exactly what I did. I said 3 times 2 is 6, and 4 times 2 is 12. We simplify that to 1/2 for our x term. 27 to the 2/3 power is 9. That's 27 squared, and the cube root of that. So what I really want you to take away here are a couple things. Number one, that I can write a square root as a fraction. I can also do complex stuff. So let's say that I had the third root of x squared. This is going to be x to the 2/3 power. Or maybe I had the square root of x to the 5th. That would be x to the 5/2 power. So you see how this, the power term goes on top and then the root term goes on the bottom. So number one, I can have these rational exponents, so these fractional exponents, and that just means I'm taking some kind of a root. And also, I've got my power rules that I have to follow. And finally, we can put this stuff in a calculator. Honestly, that's probably the fastest way to do it since you're online. And you can evaluate these things to a regular number. However, if you've got a variable, you're still going to have to follow the exponent rules and get the right exponent for the variable, though you're more than welcome to put the regular term into a calculator and get the answer.